actually given that the solution is a natural number that is a positive integer. Now, standard approach would just be to square both sides and cross multiply. And so let's write that down and see where that leads us. So we have 45 squared. No need to know what 45 squared is at this point. Okay, now when we square this, we just get 6x plus 7, right? And so you have 45 squared times 6x plus 7. Okay, now in a similar fashion, you'll end up with, and again, y'all, this is cross multiplication. So what do we end up with here? We end up with 3285. Write the constant out front. 3285 times this denominator squared, which is the binomial 3x plus 12. Right. Now you're starting to see the problem with this, right? It is doable. It's not, I wouldn't call it hard. It's just a little bit of an arithmetic strain. So it's very clear here that we can get a linear thing going on here, but 45 squared, you'd have to know what that was. Multiply it times 6, collect like terms, and you could solve it. So it's not conceptually hard, but it's arithmetically, it's a little bit of a burden. So I propose another solution here. Now, the trick, if you want to call it that, is that 3285, which is the radicand up here, is actually equal to 73 times 45, which turns out to be quite convenient. So what happens here, in a way, we unrationalize the denominator. You know that cumbersome rationalize the denominator process, where we're unrationalizing this denominator here, and we get something that's a lot more manageable. I notice you could do the standard cross multiply here. You would just have 6x plus 7 times 45 rather than the 45 squared here, okay? And you would have 73 instead of the 3285 that you see here. But you see, you are given that x is a natural number. And y'all remember, natural numbers just mean, the positive integers. Some people include 0. I normally don't really. I think that's just, who knows, But 1, 2, 3, and the customary ellipse, okay. So that's what we mean by the natural numbers. So what I'm proposing here, even though you could do the cross multiply and get to the solution relatively quickly, it's pretty easy to, and you're dealing with a natural number. Let me write that down. X, like we can't remember it, right? X is a natural number. Now you can just start checking, like, all right, let's check 1. Okay, well, 3 times 1 is 3, and that would be 16, right? But you see, we have a radicand equal to a radicand, so you can actually set just this equal to this, all right? And so when you do that, you'll get x equals to 11. And you also, that's a guess and check approach, but it's justified. We simplified it, and who cares? People argue about that all the time. But if you get it to a state where you can inspect it and get the answer, I don't have a problem with that. I don't know about the rest of you guys. But notice that 6 times 11 up here, this would give you the square root of 77, right? Also, you may as well note that 6 times 11 is 66. Plus 7 is 73. Excuse me, 73. Okay. So x equals 11 is the solution, and again, you could have got the answer just by cross multiplying. You'd have 45 times. I'll just write it down. You could just carry out this if you want to. 45 times 6x plus 7. Okay. Equals to 73. Trying to write small, folks. 73 times 3x plus 12. 73 times the binomial 3x plus 12. And again, you can work this out, and you'll get the correct answer if you like doing it that way. But you see, we're actually using the fact that x is a natural number, and you can tell the numbers aren't going to be too large. If you weren't given that x was a natural number, you might not know to guess and check. You might think you're getting a irrational solution, perhaps, or even complex, I suppose, you know. But in any event, this is the answer, and we actually benefited by this is called a rationalized denominator. A bad word, you know. This is called. Often you'll just do a problem like this to satisfy a teacher, you know. But we have an unrationalized expression here, if you want to use that language, which actually makes it easier to get the answer by inspection.